See that? We've done vertex form before. So if you remember, we had like a whole section or two or whatever it was where you guys looked at absolute value and how does it move around and up and down and things like that. Okay, so this is kind of what we're going to keep going with. This is standard form. That's what we keep talking about. Ax squared plus bx plus c. And this is going to be in function. This is a function. So y is going to remain y as we go. We're going to do things, complete the square, so that we can change it into vertex form. This gives us more information. It gives us the vertex. It gives us the axis of symmetry. It tells us which way it's opening. All those things like we did, like whatever that was, a few months ago or whatever. So that's what we're going to get done with. I don't personally like the way they do this first example. So I'm going to come back and do this first example after we do these two checks together. Okay? And then it'll make more sense what they're doing. I tried to do it first period. I started with that example, and it's unnecessarily confusing about a sign, and so I'm going to take care of that for us right here. So we're just going to start with A here at the bottom. And again, we're taking this, it's in standard form. We're going to write it in vertex form. We're going to use the idea of completing the square to do that. The difference is we do not have an equation. So everything has to be done on one side of this because a function is just a statement. Okay? So that just throws one little wrinkle into what we're doing. No different, not really different, just like a little bit of a wrinkle. So, just like before, C is not helping us get to a perfect square trinomial. But since we don't have another side, we're not going to add it to the other side. We're just going to shove it off a little bit so we can ignore it. So the first thing we're going to do is just group these first two terms together. So now we're going to go through and complete the square. And it's done the same way. So what do we have to do to that 8? Times by half, what do you get?
4.
What do you do with that?
You square it.
And you get 16. So now here's where the wrinkle comes in. We're going to say x squared plus 8x plus 4 squared, just like we always did. But then we're going to turn around and right away subtract 16. Why? Because usually that 16 we add it to the other side. So why do we have to turn around and subtract it?
There's no other side for us to subtract it to.
And so why does that make it so that we have to do this now? There is no other side, that's true. So why do we do this then? Just you're only looking at this. Why is this necessary?
It would eliminate.
And why is that important?
Because you have to cancel them out and
Okay, so
add on.
well, okay, so why were we adding it to both sides when we had an equation?
Even on both sides.
So it was balanced, yeah, right. So then basically what this is saying is we're allowed to add 0 and nothing changes.
Yeah.
So then we added this and we turned around and subtracted it like it wasn't there. We did that so that these 3 become something that we can factor. Okay, so this is kind of the wrinkle right here. But we're only looking at these. What do those factor into?
1. X plus 4.
Is that okay? Just like it did before.
Oh, yeah.
Okay.
Could you?
That's vertex form. Yeah, go ahead.
That's what I was going to ask, if you could combine the...
Yeah, you should. Because now we can say what the vertex is. So what is the vertex on this?
4. It's 4 negative 19.
Close.
Negative 19, 4.
No. -4, -19. So remember,
Oh, yeah, cause it's in the parentheses.
because it's in the parentheses, right? We always had to do the opposite when on the inside of the parentheses, right? So it moves it left and right, but in the opposite direction. The outside number moves it up and down in the same direction. What's our axis of symmetry then? X equals -4. Is this vertex a minimum or a maximum? How do you know?
No, I really don't know.
It is a minimum. How do we know?
I know the squared has something to do with it.
Since the 4 is a positive, it opens up.
That's not why it opens up. But you're on the right track. Something needs to be positive. That's why it opens up. What's positive that makes it open up?
The X.
Well, okay. So like if we go back to like kind of what they stated up here, right? It's that the A is positive. It's a positive 1.
Yeah.
Well, it is, but we just don't write it because it's 1.
Okay.
So is that okay since it opens up that makes that vertex a minimum?
Yeah. So if it was negative A, it would be a maximum.
It'd end up being a maximum because then it's upside down, right?
I got you.
So far, so good? All right. So we're gonna do 2 more examples, and then we're gonna talk about some things. All right. So again, we only have one side of the equation. That -5 is not helping us with anything. Yeah. So we're just shoving it off to the side and dealing with it later. Now all the rules are basically the same.
You do -6 times that.
Careful.
6 times 9.
Well, so either one of those is fine, except there's something about A that has to be
We
true.
have to get rid of the -3.
Yeah, A has to be 1, or otherwise it doesn't work. So before, we ended up dividing through by that -3, but we don't have 2 sides now. So now we have to factor out that -3, but just out of those 2 terms. Okay? So then what are we going to take out and multiply by 1/2?
2.
And we get what?
1.
And we do what with that number?
Square root. 1 cannot be squared, so this.
Yeah. All right, so then, right, we're working inside these parentheses. And so we're always adding that, and then we got to turn around and subtract it. And now we're only looking at these 3. And so then what do those factor into?
It'll be x squared minus 1.
X minus.
Or x minus 1. Wait, oh no, that's plus x plus 1.
So it should be x plus 1 squared. Is that okay? Right, because we're only looking at these 3. Right, everything else we're ignoring. We're just saying, okay, the trick is, because we just made this into a perfect square trinomial, the trick is, there's the x, that's the plus sign, and then there's the 1.
Where'd the 2 go?
So the negative
It
1 would be the C.
It just factored it.
Oh, okay.
No. So we're ignoring that -1. That -1 was because we had to keep it like adding 0. So this negative one's gonna come in. Okay, we're gonna deal with that here in a second, okay? But yeah, this is not C, this one was C, okay? And so again, the 2 just gets factored in here. Is that okay?
Yeah.
All right, so this is not in vertex form yet. So what we're gonna do is distribute this -3 in, but we're not gonna get carried away. So we're just gonna -3x plus 1 squared plus 3 minus 5. Is that okay? Right, so like all of this was the numbers that we were dealing with when we factored out that -3 up here, right? We just took these two numbers, started completing the square from just these two numbers. We were ignoring everything else, okay? We got a plus 1 squared, that was this, and then we had to turn around and subtract 1. But this is all inside with this -3. Is that okay? So then to get everything back to normal, we have to remember that we factored out that -3, and so then we distribute things back. And you only go to that, you don't like refoil it, or otherwise you're just gonna end up where you started. Okay? And that's why this -1 is now a +3 here. So now what we're saying is that the vertex form of this looks like this. So then where is the vertex?
-1, -2.
What's the axis of symmetry?
-1. X equals -1.
And is this a minimum or a maximum?
That would be a maximum.
Does everyone understand why it's a maximum? Now these are easy to check. You get a graphing calculator, right? You go in and put the original in, and then you put what you say it is in, and they better give you the exact same picture, because we're not changing anything, we're just rearranging things to get us some information. Okay? All right, so now let's look at their example, because then we can have some steps while we look at this. And then again, we got to talk about a couple things here. All right, so, right, they say, okay, well, this is the original function, right? Group ax squared plus bx, that's what I was saying, like C doesn't do us any good, so we just ignore it, we push it off to the side. Right, A is not positive 1, that's what it has to be. So that's why we're factoring out a -1 here. Okay, so now, right, this is where we go off to the side, and we say, you guys see that yellow? So yeah, 12 times 1/2 is what? 6 squared is, okay? And so then we're gonna add the 6 squared. And then it's gonna be, so we added it and then we subtracted it. And so then the question becomes, why is there 2 negative signs here? Where'd it go? How come you guys don't have that? That's not what it looks like on mine. What's going on? Oh. Uh-oh. Ah, boy. There it goes. There goes the recording. Okay, so again, so why do we have 2 negatives now?
Because the 36 is positive, so it has to be positive 36.
So it's positive here, that's why we have one of the subtraction signs. So we added it, and then we subtracted it. Where's this other subtraction sign come from? Or negative sign? So like, let's look back at this other example. Why is this a +3 when we were dealing with 1?
Oh, we
multiplied by
we factored, yeah.
4.
So then, like, let's look back here, right?
Oh, okay.
So then why is there 2 negatives here?
We factored out the negative.
We took out that negative, and so then we had to, we're going to distribute it. So like, I would do it down in this step, but they wrote it like this, and that's why it's minus and negative. So that's what's going on, okay? And that's why I don't like doing that one first, because then, like, I have to explain the whole thing as opposed to seeing it. So then this is gonna factor into x plus 6 squared, and then that's gonna be 27. Is that okay?